In the next 30 minutes, you will build a working AI application with Python and Amazon Bedrock. Your application will send prompts to a foundation model, maintain a multi-turn conversation, analyze an image, and call an external tool when it needs real information. Welcome to Hired in IT, where we turn technical knowledge into practical, career-ready skills. Let's build your first Bedrock application. More development roles are asking candidates to connect applications directly to foundation models. That means employers need more than someone who knows how to use an AI chatbot. They need developers who can send prompts from code, manage conversation history, handle failures, track usage, and connect models to business systems. In this video, you'll build those skills using Python, Amazon Bedrock, and the Converse API. By the end, you'll have a working AI application you can expand into a portfolio project and discuss in a technical interview. By the end of this video, you'll have 3 concrete resume-ready skills. First, a Python script that fires a prompt through the Converse API and prints the AI's answer. Second, a chatbot that stays coherent across multiple turns because you're managing conversation history like a pro. Third, the ability to feed images and hook up external tools, so the model can actually do something useful instead of just guessing. And throughout, you'll learn how to set up the right permissions. An IAM role is an AWS identity with specific permissions your code assumes, so you never embed long-term access keys. Before you start coding, make sure you have 4 things. First, an AWS account with access to Amazon Bedrock. Second, Python 3.10, or later installed on your computer. Third, the latest Boto 3 library, which is the AWS SDK for Python. And fourth, AWS credentials with permission to invoke the Bedrock model you plan to use. For local development, you can authenticate with an AWS CLI profile, IAM Identity Center, temporary credentials, or a Bedrock API key for initial experimentation. For a production application running on services such as Lambda, EC2, or ECS, use an IAM role with temporary credentials. Never place permanent AWS access keys directly inside your Python code. Before calling a model, open Amazon Bedrock in the AWS console and confirm that you are working in a region where your selected model is available. Open the model catalog and choose a model that supports the Converse API. For this demonstration, you can use a supported Anthropic Claude or Amazon Nova model. Depending on the model provider and your AWS account, access may already be enabled. Some models may require you to accept provider terms, complete a use case form, or activate access through AWS Marketplace. Copy the model ID or inference profile ID shown in the console. You'll place that value in your Python code. If your application later returns an access or model not found error, check 3 things: the model identifier, the selected AWS region, and your IAM permissions. Start by installing or upgrading Boto 3. Run pip install, upgrade Boto 3, then import Boto 3 and create a Bedrock runtime client. You can also specify the AWS region explicitly so your code always connects to the expected location. The Bedrock runtime client is the object your application uses to send inference requests. The Converse API gives supported Bedrock models a consistent message-based interface, which makes it much easier to compare or change models without redesigning your entire application. However, models do not all support exactly the same features. Before switching models, verify support for capabilities such as image input, tool use, streaming, and specific inference parameters. Recall: checkpoint, Client and Converse API. Every conversation message contains two main elements. The first is the role, which is usually either user or assistant. The second is content, which is a list of content blocks. For a basic text message, the content list contains a block with a text field. This message structure works consistently across models that support the Bedrock Converse API. That consistency is one of the biggest advantages of Converse. You do not need to learn a completely different request format for every supported model. But remember, different models may support different content types and features, so always check the model documentation before using images, tools, or other advanced capabilities. Now call the client's Converse method. Pass the model identifier and the messages list containing your user prompt. Bedrock sends the request to the selected model and returns a structured response. The same Converse method can be used with many supported Claude, Llama, Mistral, and Amazon Nova models. You may be able to switch models by changing only the model identifier, but always verify that the new model supports the features and parameters your application uses. With one Python method, your application can now communicate directly with the foundation model. The response from Converse is a nested dictionary. The chain you'll use most often is response, then output, then message, then content, then the first item's text. That's your AI's answer. Right alongside it, the usage section tells you exactly how many input and output tokens you burned. Visualize the path: response, output, message, content, text. Commit that path to memory now, and you'll never waste time digging through print statements. Extract the answer with that path, print it, and you've just built your first AI-powered Python app. One warning: some models can return multiple content parts. The first element isn't always the only one. In production code, loop through the content list rather than assuming a single block. But for now, run it and watch a foundation model reply to your prompt. 3 common settings help control how the model responds: max tokens, temperature, and top P. Max tokens limits how many tokens the model can generate. Setting a reasonable limit helps control response length, latency, and cost. Temperature controls randomness. A low temperature usually produces more consistent and predictable answers. A higher temperature introduces more variation and creativity. Top controls nucleus sampling. The model considers the most probable candidate tokens until their combined probability reaches approximately the value you specify. For a factual support assistant, you might begin with max tokens set to 200, temperature set to 0.2, and top set to 0.9. Those are starting values, not universal rules. Test them with your actual prompts and evaluate the quality, consistency, latency, and cost of the responses. Quick checkpoint: how do you structure a message and what dials let you shape the output? Pause for a second, then I'll reveal the answers. Let's lock in what we've covered. Answer these 2 questions out loud or in your head, then I'll show the answers. A user messages an IT support bot. What's the server status? The bot replies, all servers running. Then the user asks, can you restart it? Without any memory of the previous message, the AI has no idea what it refers to. Maybe a printer, a database, or nothing. That's exactly what happens when you fire one-off prompts. Each call is stateless. A multi-turn conversation fixes this by sending the entire message history with every request. That way the model sees, what's the server status? And then, can you restart it? Back to back, and it connects the dots. Next, you'll code that stateful pattern. To give the model memory, you maintain a Python list called messages. After the first user-assistant exchange, you append the assistant's response onto that list. For the follow-up, you just append the new user message and call Converse again with the entire list. The model now sees the full conversation and correctly answers questions like, "Can you restart it?" because it knows you were talking about a server. Here's the cycle in pictures. Start with just a user message and get a reply. Immediately append that assistant reply to the history list. Then when the next user message comes in, you add it and call Converse again, passing the complete history. The model now has full context and can reason across turns. This is the foundation of every useful chatbot. A system prompt defines the overall behavior you want from the model. You pass it separately from the conversation messages so it remains a consistent instruction across every turn. In this example, we tell the model to act as a concise technical support assistant and return its response in JSON format. However, asking for JSON does not guarantee that every response will be valid JSON. In a production application, validate the model's output before using it. When supported by your selected model, structured output features can provide stronger control over the required response schema. Think of the system prompt as guidance, not as a security boundary or a guaranteed enforcement mechanism. Quick recall check. First, how do you preserve conversation context? Second, the token tracking question from earlier in this series. Answer both, then I'll reveal the correct responses. A developer finishes their Bedrock integration, fires off a few test prompts, everything works. They ship the code to production, and at 3 a.m. a transient network error hits. No try, except in the code. The application crashes hard and stays down until someone wakes up and manually restarts it. That's the silent killer in most first apps. The assumption that API calls always succeed. In the next scene, you'll add a safety net that turns crashes into graceful fallbacks. Every call to an external service can fail, so wrap your Converse request in structured exception handling. Different failures require different responses. An access denied error usually means the model is unavailable to your identity or your IAM policy is missing the required permission. A validation error normally means your model ID, message structure, tool schema, or inference parameters are incorrect. Throttling, temporary service failures, and some network errors may be safe to retry using exponential backoff. Do not retry every error automatically. Retrying an invalid request or a permission failure will not fix the problem. Log enough information to diagnose the issue, but never expose credentials, sensitive prompts, private user data, or detailed internal errors to the end user. Instead, return a safe message such as, "The AI service is temporarily unavailable. Please try again." Your try, except, will catch these, but it's better to avoid them in the first place. 3 shields against the most common runtime errors. 1. Model access denied. Go enable the model in the console. 2. IAM permission missing. You need the appropriate IAM policy that allows model invocation. 3. A malformed message body. Double-check that every user and assistant turn uses the exact role and content structure. Amazon Bedrock usage is measured in tokens. Your input tokens can include more than the user's visible question. They may also include the system prompt, previous conversation messages, tool definitions, image-related processing, and other request content. Your output tokens represent the content generated by the model. The exact token count depends on the selected model, the prompt, the conversation history, and the length of the response. That means even a short user question can become expensive when it is attached to a long conversation history. The response usage fields show what the request actually consumed. Track those numbers instead of estimating your cost from the visible prompt alone. Grab the usage right after your Converse call. The input tokens and output tokens fields are plain integers you can print, log to a file, or push to a dashboard. Tracking these numbers early keeps your prototyping costs visible and painful surprises out of your monthly bill. Let's lock in what you just learned about error handling and spending. Answer these, then I'll show the correct responses. To send an image, first choose a Bedrock model that supports image input through the Converse API. Open a local image file as bytes, or securely retrieve the image from an approved source. Inside the user message, add an image content block containing the correct format and the image source. Then add a text block explaining what you want the model to examine. For example, you might send a screenshot and ask the model to identify the likely cause of an error message. Supported image formats, dimensions, file sizes, and image limits can vary, so verify the requirements for your selected model. When using Boto 3, local image bytes can be passed directly in the request. You do not need to manually convert them to base 64 first. Also remember that images may contain sensitive information. Remove passwords, access tokens, personal information, internal host names, and confidential business data before sending screenshots to a model. 2 quick questions to lock in what we've just covered, and 1 callback to part 1. Ask a model, "What's the weather in New York right now?" Without live data, it might confidently answer, "Sunny, 72 degrees," a hallucination pulled from thin air. To give the model access to real-time APIs, Bedrock supports tools. You define a function the model can request, your code actually runs it, and the model uses the real result to compose its answer. That handshake is what we build next. Here is how tool use works. First, your application sends the user's request along with definitions of the tools the model is allowed to request. If the model decides that it needs a tool, it returns a tool use request containing the tool name, input arguments, and a unique tool use ID. The model does not execute the function itself. Your application validates the request, checks that the user is authorized, and runs the approved function. Next, your code sends the function result back to the model in a tool result content block that includes the matching tool use ID. The model then uses that result to generate its final answer. This separation is important. The model decides what information it needs, but your application controls whether and how the action is performed. Define a list with a single tool spec. The name is what the model will call, the description helps it decide when to use it, and the input schema declares exactly what arguments it must supply. This schema is JSON-based, so you can reuse the same shape for any tool your app exposes. Pass the available tool definitions to Converse using toolConfig. The model may respond with a normal final answer, or it may return a stop reason indicating that it wants to use a tool. Do not assume that every response contains text. First, inspect the stop reason and the returned content blocks. If the response requests a tool, locate the tool use block and extract its name, input arguments, and tool use ID. Before executing anything, confirm that the requested tool appears on your approved allow list and validate every argument against the expected schema. Never pass unvalidated model-generated input directly into a shell command, database query, file path, or privileged cloud operation. The model has returned a tool use request. First, append the assistant message containing that request to your conversation history. This preserves the complete sequence of the conversation. Next, validate the requested tool name and its arguments. For this demonstration, our approved function returns the current service status from a small local data source. In a real application, the function might call an API, query a database, check an S3 bucket, or retrieve information from an internal system. Your Python code, not the model, executes that function. Then create a user message containing a tool result block. Include the original tool use ID so Bedrock can match the result to the correct request. Append that tool result message to the conversation and call Converse again. Now the model has the verified information it requested and can generate a final answer grounded in the tool's result. Checkpoint. Tool use recap. Here's the whole cycle in one picture. You start with a message history and send it to the Converse API. If the model doesn't need a tool, you get a final answer. But if stop reason is tool use, you pivot, extract the tool request, run the actual function, wrap the result back into a tool result message and append it. Then you call Converse again with the updated history. This loop keeps spinning until the model has everything it needs to produce a real answer, not a guess. Before turning your prototype into a real application, follow these habits. First, use a clear system prompt, but do not treat prompts as guaranteed enforcement. Second, validate model outputs before sending them to another application or displaying them to users. Third, handle failures by separating permanent errors from temporary errors and retrying only when appropriate. Fourth, track input tokens, output tokens, latency, model IDs, stop reasons, and application errors. Fifth, never hardcode long-term AWS credentials. Use temporary credentials and IAM roles with least privilege permissions. Sixth, validate every tool request and require additional authorization or user confirmation before performing sensitive or destructive actions. Seventh, manage conversation history. Long conversations increase cost and may eventually exceed the model's context window. Finally, test more than one model. Compare response quality, speed, supported features, and cost for your specific use case. These practices are what turn a demonstration into the foundation of a production application. Let's compare common beginner mistakes with professional development practices. A beginner forgets to append the assistant response to the conversation history. A professional preserves every required user, assistant, tool request, and tool result message in the correct order. A beginner assumes every response contains text. A professional checks the stop reason and inspects every returned content block. A beginner executes whatever tool and arguments the model requests. A professional uses an allow list, validates the schema, checks user authorization, and limits each tool's permissions. A beginner sends the full conversation forever. A professional monitors context size and trims, summarizes, or retrieves only the history that is still relevant. A beginner uses default inference settings for every task. A professional tests settings against measurable requirements for quality, consistency, latency, and cost. And a beginner hard-codes credentials. A professional uses temporary credentials and least privilege IAM roles. These practices make your application safer, cheaper, and more reliable. Look at what you have built. You started by connecting Python to a foundation model through Amazon Bedrock. Then, you created a multi-turn conversation by preserving message history. You added a system prompt to guide the model's behavior. You handled errors, tracked token usage, and sent an image alongside text. Finally, you added tool use, so the model could request verified information from outside its training data. You have not completed every part of production AI engineering yet. Topics such as streaming, persistent storage, evaluations, guardrails, observability, authentication, deployment, and prompt injection defenses still matter. But you now have something important: a functional AI application prototype and a strong foundation for building more advanced systems. Let's confirm what you accomplished. You built a Python application that sends a prompt to a Bedrock foundation model and reads the response. You created a multi-turn conversation that maintains context by resending the required message history. You added image input for a supported multimodal model, and you implemented a tool use cycle in which the model requests information, your Python code runs an approved function, and the result is returned to the model. That is more than a basic API demonstration. It is the foundation of a real conversational AI application that you can continue developing into a portfolio project. Here is your challenge. Take the application you built today and replace the demonstration tool with one real function. You could check whether an S3 bucket exists, retrieve the status of a test service, read an approved local JSON file, or query a public API. Validate the tool arguments, handle errors, record the token usage, and document how the full request cycle works. Then place the project in a GitHub repository with a README, an architecture diagram, setup instructions, and screenshots of the application running. That turns today's lesson into something you can demonstrate during an interview. In the next lesson, we'll go beyond the first working prototype. You'll learn how to compare Bedrock models, choose the right model for a workload, evaluate response quality, and understand the trade-offs between capability, speed, and cost. Subscribe and turn on notifications so you can continue building the complete application step by step. The fastest way to understand AI application development is to build, test, and improve something yourself. Your first version does not need to be perfect. Start with one useful problem, connect one model, add one carefully controlled tool, and document what you learned. Every error you troubleshoot and every improvement you make becomes experience you can discuss in your next interview. Careers are not built by watching tutorials alone. Choose one feature from today's lesson, implement it, test it, secure it, and explain how it works. That is how technical knowledge becomes practical experience. Thanks for watching Hired in IT, where we turn IT knowledge into career opportunities.